Hello students, I hope you're all doing well. And here is another instance of the unofficial and unsupported C++ tutorial in case you have forgotten things from your C++ class that you kind of, might need a little refreshing to remember to hit the ground running. So in the previous video we talked about data structures. And data structures not in the way we mean for the data structures class we're in right now. And if you're not in the data structures class and you're watching this and you're wondering what I'm talking about, just ignore it. We're talking about struct, the data organization method in C and C++. So the previous video we talked about three different kinds of ways of making structured data in C and C++. But yeah, all the same data structures we saw in the previous lecture work in C++. Just want to reiterate that. Yeah, so if you want to try that using C++ compiler, go ahead. Yeah, okay. And remember, I alluded to this last time that sometimes we want to have more functionality built into our data structures than just, being able to store single variables. Sometimes we want some functionality built into it, like, if we make a structure or a data structure called class, we might want a function built into it that computes like the average grade of the class or something like that. So this is where classes come in really handy. So classes look a lot like data structures, but they're way, way more functional. They're very, very robust. So let's take a look at the way we declared a struct from our previous lecture. So we had our type def saying it was a structure, and then the name that we're going to associate with a structure type, and then we had a list of fields within that structure. In other words, a list of variables that's part of this struct type. Well, if we want to change this to be a C++ class, we just take this line out, replace it with the name class, or the word class. We take name and move it up behind class, and then we have our field list. Now, one of the things you can't forget is you're still going to have this semicolon down here. Common bug, when writing classes, is just leaving that off, but got to keep that guy there. Okay. So, if you want to try this in code, go ahead and do that. Now, one of the things that you're going to have to do is you have to specify what are called access specifiers. And that's whether or not your variables or functions are public, private, or protected. Very seldom you end up using protected. In reality, most of the time you're going to be dealing with public and private functions. So public functions or public variables are accessible by whatever is calling your class that you've made. Private variables are only accessible by functions inside of your class, so things that you've written. And that, that can be a little bit confusing. So like I said, in order to access variables or functions that are built into your class, they need to be in public. So have the public access specifier. And, this lets you protect certain aspects of your program, or certain aspects of your class. Say you design a class that does a certain calculation, and you want to protect some variables so that people utilizing the class don't modify them. You can do that, and that's what the public and private specifiers are there for. So yeah, we can sort of treat classes like their own little autonomous programs. Like they have their own startup functions, and they have their own ending functions, and they have other functions built into them that you can call, that you, the programmer, can make. So this is where we start getting into the big differences between classes and structs. You can restrict access between what can be accessed outside the class and what can be accessed inside the class. And you can actually add functionality to it. You can add literal functions to inside your class. So you can call your class type dot function name and have it perform some sort of procedure. Yeah, now this is where we get into something interesting. some of you I've noticed, so let's say that this was public. So we had public here as access specifier, and we had, say, int, or maybe double average, and this was a function to calculate an average. What I've seen a lot of you do is actually write your whole function right here. That technically works, but that's really bad practice. What you should really do inside your class is just write what's called the prototype for your function. So the data type, the function name, and the input parameters, and nothing else. And end it with a semicolon. Nothing else. It will technically work if you write your whole function right here, but it's going to break a lot of stuff later on if you're wanting to use things like variables that are in your private section and you end up including it lower in your program. It's just way cleaner and a lot easier if you only put your what's called your function prototype. In other words, the return type, the function name, and its input parameters inside your class definition. Okay? So where do those actual functions go? They go after you've written this thing. So down lower in your file, usually immediately after doing your class definition, you can start writing the functions. And member functions for your C++ class look shockingly similar to what they look like when you write just a regular function. But there are a few minor differences. The minor difference is as part of the first line of your function here. You're going to have your return type, you're going to have your function name, your input parameters, but in between return type and function name, you're going to have to put the class name that you're using, colon, colon, and then the name of your function. So this is what associates this function name with the prototype that you had written inside of your class definition. So this is the way to do it. That's the way to go about this. Okay, so if you wanted to try coding up some of this, you can actually copy and paste a lot of this, and you've got to use like sensical names here for your class, and write something that makes sense, like instead of data type, like int function whatever. Okay, oh yeah, so what if we want to initialize things? Well, if we want to create a class and then initialize it to something. Remember, we couldn't just have it default initialized to things with our structs. Well, we can do that with our classes, and this is where we get into what's called a constructor. A constructor looks like a function definition like we just looked like for your class, except there's no return type. And instead of having a function name, it's just class name, colon, colon, class name again. And that's how your compiler is going to know that this function is the first thing that should be called when you make an instance of a class. It looks for your class name, colon, colon, class name. That's just the way you got to specify it. So you can use this function to set up all of the nifty stuff, like initializing your variables, setting up like your current pointer, your next pointers, or whatever for your classes. But you also have to make sure there's a prototype for this as well in your class definition. So usually under your public access specifier, you put class, your class name, as if it were a function. So the exact same thing here that you called your class, write it here. Put an open parentheses and a closed parentheses and a semicolon, and that makes a default constructor. You can also specify input parameters like you can for other functions for your constructor, but it's good practice to have that in addition to one that's your, and I'm air quoting here, default constructor, which is going to be the guy that gets called no matter whether or not you give it input parameters. So yeah, your constructor, like Bob the Builder. Do people still watch Bob the Builder? And if they do, has he been rebooted, and does he still look like this? Who knows? Oh yeah, and your constructor must be in the public function, or public specifier section. Give that a try. Yeah, we've talked about the default constructor already. And you can overload your constructors, meaning you can have versions of your constructor that you give input parameters to. Sort of like what you've probably already seen with like the string stream class when you would make a new instance of that, you could give it an input parameter, so the string that you wanted us to parse, for instance. And that's called an overloaded constructor. And again, it looks just like your other constructor and function declarations for a class. So class name, colon, colon, class name, and then in parentheses, the input parameters that you'll be passing into your function. Okay, now this is interesting. Didn't we just introduce a memory leak? So if we're declaring all of this stuff and probably some pointers and allocating some memory in here, doesn't that mean that, when we're done, we've just left all that hanging? Well, yeah, it is. Oh no! Terrifying! So bad! Well, can we set up a function to clean up for us when we're finished using our function? And yes, we can. This is called a destructor. And a destructor is a function that you want to call when your class is no longer being used. So what you can do is you can put code in here that frees up pointers, deallocates things, closes files if you got file pointers open. And so this is your destructor. It looks, in the way it's defined, exactly the same way as your constructor, except you put your little squiggle right there. So class name, colon, colon, tilde, class name. And then all the stuff you want to do when your function's no longer used, like freeing up memory, deallocating things, closing files, that's what you're going to want to do in here. Yeah, but we've also got to add a prototype inside of your class definition for this as well. And again, it looks identical, like literally identical to how you make the prototype for your constructor, except you put your little squiggle in front. So yeah, not terribly bad at all. Yeah, that's our Destructor for Futurama fans. Okay, so that gets us at the end of our brief overview of classes. I hope you guys are doing well, staying happy, healthy, and safe. Again, this isn't officially part of the class, just a little happy I'm making for those of you who might need a little reminder to how these things kind of work for C++. Again, I hope you're all doing well, and I will see you on the flip side.